In a recent year, which we know is 365 days, a hospital had 5,381 births. We want to be able to find the mean number of births per day. In order to find the mean number of births per day, we need to divide the number of births in a year by the number of days in a year. And so we calculate the mean and then rounding it to one decimal place. So the mean is going to equal 5,381 births divided by 365 days, which gives us 14.724465, and rounding it to one decimal place gives us 14.7. Now, therefore, the mean number of births per day is 14.7. In part B, we want to find the probability that in a single day there are 13 births. So to find the probability of an event occurring X times over an interval, you use either technology or the Poisson probability distribution formula, which is given below, where the value of E is equal to 2.71828, and the mean is the number of occurrences of the event in the intervals. So here is our formula. So we know that the mean in our problem is equal to 14.7. And we know that X is equal to 13 because it's exactly 13. And we know the value of E is equal to 2.71828. So when we use the formula, we know that our mean is 14.7, and we're raising that to the power of 13, and then we're going to multiply that by 2.71828, and that's to the power of negative 14.7, and then we're going to divide that by x, which is 13 factorial. Okay, so in this case here, if we open up our calculator here, okay, we're going to do the numerator first. We're going to say left parenthesis 14.7, and then we're going to raise that to the 13th power, shift and say multiply left parenthesis 2.71828 parenthesis, and then raise that to the negative 14.7 power. We get that value. Now we need to divide that by 13 factorial. So we're going to hit divide 13. We're going to select math, go to the probability, and then scroll down to where it says factorial symbol, and then press enter. And then we get that value for the probability. And now what we're going to do is we're going to compare that to what it would be on the StatCrunch. So using StatCrunch, we're going to select Stat, highlight Calculators, and then select Poisson. And then in a dialog box, we're going to enter the value of the mean to be 14.7 and the value of X, which is equal to 13, because we're finding the probability that in a single day there are 13 births, which means probability of exactly 13, which is equal to the probability of X is equal to 13. And then we're going to click Compute. Okay, so now we're going to open up StatCrunch, and then we're going to select Stat, we're going to go to Calculators, and we're going to scroll all the way down to where it says Poisson. So we know that our mean that we found is 14.7, and we know that we're finding exactly 13, so we want to set this to be equal to 13, and then we're going to select Compute. And then if you take a look at the value here for our probability and compare it to the one that we have in our calculator, it's very close. Now again, this number at the very end of our StatCrunch number compared to the calculator, the reason why they're slightly different at the very end is because we're using 2.71828, but then we can keep going with that number and it's not extended. And here in StatCrunch, it's actually more accurate. Therefore, if we run it to 4 decimal places, you're going to see that we get the exact same value, rounding it to 4 decimal places. So therefore, we would say that the probability that in a day there are 13 births is 0.0992. Now in part C, it says to find the probability that in a single day there are no births. Would 0 births in a single day be a significantly low number of births? Now, to find the probability of an event occurring x times over an interval, we're going to use either technology or the Poisson probability distribution formula, which is given below, where again E is approximately 2.71828, and the mean is the number of occurrences of the event in the intervals. So in this case here, we're going to continue with StatCrunch. We're going to select Stat again, Calculators, and select Poisson, which we already have. We already know what the mean is, which is 14.7. And now the value of x is equal to 0, because x is equal to 0 is that the probability that in a single day there are no births. So therefore, no births means exactly 0, which is x is equal to 0, and then we're going to select compute. So let's go ahead and put in here. So we got our mean of 14.7. We know that we want to put in the value of 0, and then we're going to select compute. So when we do that, you can see what we get rounded to 4 decimal places. And that value you can see is going to be 0.000. So therefore, we would say that the probability that in a single day there are no births is 0.0000. Now, would 0 births in a single day be a significantly low number of births? Well, we have to compare that to 0.05, and 0.0000 is less than 0.05, and so we would say yes. And that is because the probability is 0.05 or less.